Now here's question number 3. Let's see what this says. A van travels with constant acceleration along a straight horizontal road. All right. The van passes at a point A with speed u meters per second, and 20 seconds later it passes a point B. The distance AB is 400 meters, show that u is equals to 12. Now in scenarios like these, I always recommend my students to sort of make a rough sketch, okay, and you'll notice that it's not just me who recommends rough sketches, the examiners also encourage, and they do mention that students who sort of go the extra mile, make a rough sketch, are better able to interpret the question, and if they're better able to interpret the question, they're able to answer it correctly as well. So these are the 2 points A and B as mentioned in the question. What is the distance? The distance is 400, so we have S, or you can say the displacement also. The initial velocity is u, so let's write u as u only. The final velocity is equal to 28 as the question says. How long does it take to go from A to B? That is equal to 20 seconds. Okay, now this is all the information that we're given here. Okay, and with the help of this information, we're supposed to show that u is equals to 12. Okay, so let's do a bit of trial and error. Let's see what formula we can fit over here. So S is equals to ut plus half at square is usually the go-to choice, but the problem here is that we don't have u, and we also don't have the acceleration. Okay, so since we don't have the initial velocity and also the acceleration, that means we can't use this formula. Okay, now there's another formula where we don't have to use the acceleration, and that is basically u plus v upon 2 times t. We can use this formula, and we have enough information to do so as well. So 400, which is the displacement, is equals to u plus v, so that means u plus 28 upon 2 multiplied by time, which is equal to 20 seconds. Yep, so far so good. So we cross out the 0 from both sides, we can cross out the 2 here, and what we're left with is simply 40 is equals to u plus 28, which means u is equals to 40 minus 28, and what's that equal to? That's equal to 12 meters per second, and that is the answer to the first part. Now, let's have a look at part B. So part B says, find the time taken for the van to travel from A to the midpoint of AB. Okay, it's a 5-mark question, so keep that in mind. So from A to the midpoint of AB. So everything remains the same. And we obviously can't say 10 seconds. Okay. So here is what we're going to do. Because it's not traveling at a constant speed. The acceleration is constant, but the speed is not constant. So we can't just say, okay, that if it takes 20 seconds to travel 400 meters, it's going to take 10 seconds to travel 200 meters. We can't say that because the speed is constantly changing. The acceleration, however, is constant. Okay, so we're going to cross this out because we don't need this anymore. In fact, you know what? Let's keep it. Instead, let's write it from here. Let's write it here. So the time taken to travel from A to B is 20 seconds, and there's a point M, which is the midpoint. And what we're supposed to do is we're supposed to calculate the time taken to travel from A to M. That's what we're supposed to find out. And what is AM equal to? AM is equals to 200 meters. Okay. Now, as you saw that I mentioned, acceleration will be constant. So that means what we can do is we can find out the acceleration. Okay, so let's find out the acceleration, for which we can use v is equals to u plus at. So v is the final velocity, that's 28. U is the initial velocity, which we just worked out, equals to a, which we don't know. And how long does it take to reach the velocity of 28? That's 20 seconds given in the previous part. So 28 minus 12, that's equal to 16. So 16 is equals to 20a, which means a is equals to 16 upon 20 or 8 upon 10, which is 0.8 meter per second square. Now this is what will come in handy now. Now we know that the initial velocity is equals to 12. We know that the acceleration is equals to 0.8. We know that the displacement is equal to 200, and what we're supposed to find out is the time. So what is the appropriate equation that I can use? That's equal to ut plus half at square. S is equals to ut plus half at square. So S is 200, ut would be 12 times t, plus 1 upon 2 times a, which is 0.8 times t square. So 200 is equals to 12t plus 0.4, since 0.8 divided by 2 is 0.4 t square. Let's get all the terms on the right hand sides. So we have 0.4 t square plus 12t minus 200 is equals to 0. Now we're going to solve this, and we're going to solve this using the quadratic formula. Okay, I wouldn't suggest you do middle term breaking here because it's going to be very difficult, and there is no guarantee whether we can do it with the help of middle term breaking or not. So t will be equal to minus 12 plus minus square root of b square, so that would be 12 squared, minus 4 into a, which is 0.4, into c, which is minus 200, divided by 2a, so that's 2 times 0.4. Now, obviously, since we're solving for t, that means we can only take the positive value since time cannot be negative. And when you solve this, the correct value that you will get will be 11.9258. Okay, and correct to 3 significant figures, it's going to be 11.9 seconds. So that is the answer to part B. Now, there's a part C also, and since we don't have a lot of space, let's do it here only. Part C says, the van has a mass of 1200 kg. During its motion, the van experiences a constant resistive force of magnitude 260 Newton. Find the magnitude of the driving force exerted by the engine of the van as it travels from A to B. Okay, so it's a horizontal road, so we don't have to worry about the weight component acting parallel or perpendicular to the plane or friction or anything. So F net is equals to mass times acceleration. Actually, we don't have to calculate friction because the only resistive force there is, we're already given that. So F net is basically all the forces that are acting in the direction in which the object is moving. So we can call it forward forces minus the backward forces is equals to mass times acceleration. So the only forward force is the driving force. The only backward force is the resistive force, which is 260 given in the question, is equals to mass, which is 1200, also given in the question right here. You can see here's the mass, here is the mass, here's the resistive force, and we're supposed to find out the driving force. And what about the acceleration? We worked out the acceleration to be equal to 0.8. So that's what we're going to use here, 0.8. Let's work this out. So once you find out the value of D, you get 1220 Newton, and that is the answer to part C and also the end of this question.